Hey guys, so yesterday we did direct variation equations, which are just lines that go through the point 0, 0. So we're going to do some more with lines today. These are going to be in slope-intercept form, which is everybody's favorite. So we're going to be answering the questions, how are the slope and intercept helpful in graphing linear functions? And then we're going to graph those functions using the slope and intercept of equation and then write equations based on the point and slope or 2 points. So we have a few vocab words. Most of these you'll be very familiar with. The slope is just the ratio of the vertical change to the horizontal change. Usually we call it rise over run. The function whose graph makes a line is called a linear function, and we can write linear functions using a linear equation. So as long as it's y equals some value, as long as it's a number or it's x not raised to any power, those are all linear functions. The y-intercept is where it crosses the y-axis when you graph it, and the x-intercept is where it crosses the x-axis. And here's our slope-intercept form, y equals mx plus b, where m is the slope of the line, and b is our y-intercept, where it crosses the y-axis. Hopefully you remember that to find slope, you use this little formula right here. We have 2 points, x1, y1, x2, y2. You take and subtract y2 minus y1 over x2 minus x1, and that is your slope. And that y equals mx plus b. That's how you find m if you're given 2 points. So let's go ahead and just start by finding slope. If I give you 2 points, let's go ahead and find the slope of these 2 points. I'm just going to go ahead and label them x1, y1, x2, y2. Now remember, for slope, we take y2 minus y1 over x2 minus x1. And our y2 is 4 minus our y1 is 7 over our x2 is negative 2 minus our x1, negative 3. So since we're going to subtract a negative, we will add. So 4 minus 7 is negative 3 over negative 2 plus 1 is 1. So our slope is negative 3. Okay, I'll go ahead and do the next one with you, and then I'm going to give you a chance to do the last one. So the slope of that one is 0. Go ahead and pause it, see if you can figure out the slope of the next one. Alright, when you do this one, you get 4 over 0. Can we ever divide a number by 0? The answer would be no. So this would be an undefined slope. When is a function not a function? Do you remember from the last section? When it passes through one or more points. So these are going to be vertical lines, whereas the 0 slopes, those are going to be horizontal lines. Alright, go ahead and try a couple of these, see what you come up with. I found the slope of the first one is negative 1, the slope of the second one is 1, and the last one is undefined again. Okay, so here's just a summary. If we have something with a positive slope, that means it's going to move in an upward direction from left to right, just like we read. Negative slope is down, 0 slope is horizontal, and undefined slope is vertical. So we're going to find equations of each one of these lines. Alright, so if I tell you that the slope is 1/5 and the y-intercept is 0, negative 3, if we use our equation, y equals mx plus b, we just put that 1/5 in for m, so y equals 1/5 x, and then your b is that y coordinate, so minus 3. That's it, you're done. Okay, what about this one? If we look at the graph, what is we need to find our slope and our y-intercept. So the easy one is the y-intercept. Where does it cross the y-axis? Right there at 1, 2, 3, 4. And our slope, we go down 3 over 1. So our slope is negative 3. So our equation is y equals negative 3x plus 4. And that's the equation of that line. Alright, so if we were given a function like this, we can write it in slope-intercept form. We want to get the y value by itself, so first we're going to start by subtracting 5x from both sides. So I get negative 4y equals negative 5x plus 16. Now in order to get y by itself, we divide everything by negative 4. So I get y equals positive 5/4 x minus 4. There you go. So our slope, our m, is 5/4, and our y-intercept, our b, is negative 4. Okay, go ahead and try this one. Okay, how would we get the y by itself? Multiply everything by 2. Make sure you multiply everything. These cancel, so I get y equals, excuse me, 3/2 x minus 2. Okay, for graphing an equation, we can graph easily when it's in slope-intercept form because we just plot the intercept and then we use the slope from there. So let's go ahead and convert this into slope-intercept form. I'm going to add 2x to both sides. So I get y equals 2x plus 1. Alright, so let's see. When we start this, we're going to start at this plus 1. That's our y-intercept. We know it crosses the y-axis at 1. And our slope is 2. We can also write that as 2 over 1. So that means from that point we go up 2 and over 1. And then we can connect the dots. There you go. We just made a graph. Okay, go ahead and try this one. Alright, so this one, when I solved it, I got y equals 4/7x minus 2. So I'm going to start down here on my y-intercept, negative 2. Go up 4, 1, 2, 3, 4. Go right 7, 1, 2, 3, 4, 5, 6, 7. And then I just connect those dots. And that's it. Have a good night.